Hey guys, it's Miss Johnson here, and I'm here to bring you our notes for Unit 5 Notes 4, which is on quadratic applications. So today we're going to talk about how we use all those things that we've been doing in the quadratics unit. The first question talks about the height of an object being propelled upward with an initial velocity v is represented by that quadratic equation. And there's a lot of variables in there that need substituting. So where g is the gravitational pull, h is the initial height, and then we already talked about that v, which is initial velocity. So it says, suppose an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the ball 2 meters above the ground. Suppose the gravity constant on the moon is 1.6. So let's just talk about all those numbers that are given to us. And we want to figure out how long is it going to take for this baseball to hit the ground if the person is standing on the moon, the astronaut. So we've got an initial velocity of 10 meters per second. That's going to be our v. That goes with that initial velocity v variable right there. Then we've got the ball 2 meters above the ground, which is h, and we've got a gravity constant of 1.6, which is g. So I'm going to take all that and plug it into my equation. I've got h equals negative 1/2 times that 1.6 gravity constant times t squared, because t is what I'm trying to find, and plus the initial velocity, which is 10 times t, and then plus the height, which is 2. So now I want to figure out when this baseball is going to hit the ground. So that means I'm going to have an ending height of 0. So I have 0 equals negative 1/2 times 1.6. We can go ahead and multiply those two together since they're constant anyways, and I get negative 0.8. That's all the coefficient for the t squared. So that's actually my a value there, plus 10t plus 2. And then I need to solve this. So I have just the fact that there's a decimal in the front leads me to believe that I'm going to need to use the quadratic formula. I could probably try to factor this, but factoring with decimals is just not as easy as it looks. So I'm just going to go ahead and jump straight to the quadratic formula. So when I plug that in, I've got t is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2 times a. So then I need to go through and simplify. We want to simplify underneath the radical first. So I have negative 10 plus or minus 100. I know 10 squared. And then when I plug in negative 4 times negative 0.8 times 2 into my calculator, I end up getting 6.4. And that's a positive because I've got negative times negative, which gives me a positive there. And then on the bottom, 2 times negative 0.8 or 0.8 is negative 1.6, which is what we already had. And then I can keep going with that. I end up with t equaling negative 10 plus or minus the square root of 106.4. There's a decimal point in there, and then divided by negative 1.6. Okay, let's plug that into the radical. Take the square root of 106.4, and I get about 10.32 there. So I've got t is equal to negative 10 plus or minus 10.32 if I round that over negative 1.6. Okay, so now this is where it splits, and we've got two possible answers here. So I'm going to split this off into my two choices. One of them is going to be the plus version, negative 10 plus 10.32 over negative 1.6, and the other one's the minus, negative 10 minus 10.32 over negative 1.6. Now, if you take a look at the plus version, negative 10 plus 10.32 is going to give me a positive number on the top. It's going to be positive 32 hundredths. If I take a positive and divide it by this negative that's on the bottom, that's going to give me a negative answer. So that one is out because I'm talking about time here, and I can't have negative seconds. When I plug the other one in, negative 10 minus 10.32, and then divide by negative 1.6, I get about 12.7 seconds there. So So that's what I'm looking at on the moon. It's going to take 12.7 seconds for that baseball to hit the ground. Now part B, 12.7 seconds is kind of a long time. It doesn't sound like a long time, but it's kind of a long time for a baseball to go up and hit the ground. Now let's look at part B. In part B, now we want to compare that to what happens if we do it on Earth. So if we do it on Earth, that our gravity constant is 9.8. So I need to go ahead and plug that into where I have G. So I'm going to get rid of this 1.6 and I'm going to plug in the 9.8 down below. That means my formula now looks like this. I've got 0 equals uh, -1/2 times 9.8 t squared. And the rest of it's the same, plus 10t plus 2. So I've got 0 equals -4.9 t squared plus 10t plus 2. And that's the equation that I'm now working with. So I'm going to go ahead and plug that into my quadratic formula. T is going to equal, opposite of b is still -10, plus or minus the square root of b squared minus 4 times a, -4.9, times c, which is 2, and it's all over 2 times a. Simplifying that, if I put all that stuff in under the radical together, I end up with, where did it go? 139.2 underneath my radical sign, and -9.8 on the bottom. And then when I take the square root of square root of 139.2, I get about 11.7. So t is equal to -10 plus or minus 11.7 all over -9.8. And again, this is where it splits. So I've got t is equal to -10 plus 11.7 all over -9.8, and t is equal to -10 minus 11.7 all over -9.8. Again, on the top over here, if I've got -10 plus 11.7, I'm going to end up with a positive 1.7. And a positive 1.7 divided by a -9.8 gives me negative time. And that one we can't use. We've got to have positive time. So -10 minus 11.7 and then divided by -9.8, this gives me approximately 2.2 seconds when I take care of that. So now on Earth, that baseball fell in 2.2 seconds. Now you can see the difference between what's happening up on the moon and what's happening down on Earth. So things take a lot longer to fall back down to the ground when they're on the moon. Let's take a look at number 2. Projectile shot vertically up in the air from ground level. Its distance s is in feet and t is seconds, is given by that equation. Find the value of t when s is 96. So I'm going to take this 96 and I'm going to plug it in for my s. That's my distance in whatever it's measured in. So I've got 96 is equal to 96t minus 16t squared. Now, I don't know about you, but I really like it when my t squared term is in front, so I'm going to go ahead and rewrite that. That's going to be -16t squared plus 96t. Now it's in standard form, and now it's a little bit easier to work with. So then I need to subtract the 96 because it's got to be equal to 0. I can't solve it until it's equal to 0. So I got 0 equals -16t squared plus 96t minus 96. And now I'm ready. Quadratic formula. Here's my a, here's my b, here's my c. So I've got t is equal to -96 plus or minus the square root of 96 squared minus 4, oh, I'm going to run out of room, times -16 times a -96. Woo. Sorry, that got a little messy there at the end. So 2 times -16 on the bottom, that's my 2a. If you need help with quadratic formula or you don't remember how to use it, you can always refer back to the videos from last trimester. Quadratic formula was like Unit 5 Notes 2 or 3, and that will help refresh your memory on how we use that quadratic formula and what it looks like. So if I keep going here, I've got -96. I've got to simplify underneath the radical first. I have to. So underneath the radical, I end up with 9,216 minus this time because I've got a negative times a negative times a negative again. These two gave me a positive, but then I multiply that by a third negative and it goes back to this negative. So minus the 6,144 that I got when I put those three together. The bottom, 2 times negative 16 is negative 32. Subtracting those, I have negative 96 plus or minus the square root of 3072 divided by negative 32. And taking the square root, I get t is equal to negative 96 plus or minus 55.43 approximately, all over negative 32. So then I'm ready to split it off. I'm going to split it off over here to the left since I have a little bit of space. I have the first one, t is equal to negative 96 plus 55.43, and that's all over negative 32. When I add those two together, negative 96 plus 55.43 is still a negative number. So, and then I take all that and divide it by the negative 32, and I get approximately 1.27. The other one on the bottom, t is equal to negative 96 minus 55.43 all over negative 32. That's going to give me t is approximately 4.73. So I've got two possible answers here, and both of them were positive seconds. Now, let's think about what that might mean. Now, this is a projectile. We assume that it's going to start going up, and then it's going to turn and come back down. And we wanted to know, where did it reach 96 feet? So we found that it reached 96 feet at both 1.27 seconds and then reached the top, whatever this maximum was, and then came back down, hit 96 feet again at 4.73 seconds. So that's why we ended up with two possible answers here, and both of them are true. It just means that one of them we reached going up, and then it turned and came back down and reached the other one. So both of those answers are true. Let's try number 3. In number 3, I'm trying to work with the volume of a pan, and it's formed by cutting 2 centimeters by 2 centimeter squares from each corner, and then the metal sides are folded up. We know that the volume is 441 square centimeters, and so we want to figure out what should the dimensions of the pan be. Now, I need to refresh my memory on how I find the volume of something. I know that volume is going to be equal to length times width times height. So if I look at the length, width, and height of this picture, I'm going to have a length of x minus 4, and the pan is a square. I know that it's going to be a square because this is the same dimension. So I also have a width of x minus 4, and then I have a height of 2 because that's what's going to be folded up from the pan. Okay, so I got to put all that together. Now, you're going to have to FOIL the x minus 4 times x minus 4, or put it in the box that we've done before, where you've got x, negative 4, x, negative 4, and find the products on the inside, and I get a positive 16. So this ends up being x squared minus 8x after putting my like terms together, and then plus 16, but I still have to multiply by 2. So now I need to go back and distribute that 2 into all parts, and I get v is equal to 2x squared minus 16x plus 32. All right, now the next thing that I'm told, I know the volume. I can plug it in for v. 441 is equal to 2x squared minus 16x plus 32. I'm getting closer. I'm almost ready to solve this. So now I'm going to subtract the 441 so that it's equal to 0, and I can solve it from there. So I have 0 equals 2x squared minus 16x, and then 32 minus 441 gives me negative 409. Whew, okay, so now I'm finally ready to drop this into quadratic formula and figure out what x is. So I've got x is equal to the opposite of b plus or minus square root of negative 16 squared minus 4 times a times c all over 2a. Simplifying all underneath the radical, if I take 16 squared and then minus 4 times 2 times negative 409, I end up with, I get a total there of 3,528. And you can go ahead and check all of this on your calculator too to make sure that you're entering things in correctly. In fact, you should be doing that. You need to make sure that you're entering all your stuff in correctly so that you're using your calculator in the right way. If I keep going here, the square root of that is about 59.4 all over 4. So then when I split that into two answers, I ended up with x being approximately 18.84 or 85. And I also ended up with x being approximately negative 10.85. Okay, so now here's the thing. We're talking about dimensions of a pan. So it doesn't really make sense for us to have a dimension of negative 10.85 inches. So I know that I'm using this x value, but now I need to figure out what that x actually tells me. I know that that means that this is the whole length of that sheet of metal that's going to be used to make the pan. But I know that the dimension of the pan is this x minus 4. So I need to take the 18.85 that I found and subtract 4 inches, which gives me 14.45. So that means that's the measure of the length and the width because it's a square pan. And we already knew the height, so 14.45 centimeters. The width is going to be the same. So 14.45 centimeters by 14.45 centimeters, and the height we already knew was 2 centimeters. Whew, that's a pretty crazy question, but you know, that's a classic MCA question, and you're going to see questions like that a lot. So, okay, let's try the last one. On the back, Jimmy John's is tracking its sales of subs. The manager sees the quadratic representing this is y is equal to negative 25x squared plus 250x plus 400. So we want to find the maximum revenue. We want to find the vertex and axis of symmetry, and the reason we're finding the vertex and axis of symmetry is because we want the max. Anytime you hear max or minimum, that tells you vertex. So let's think back to our vertex formula, and our vertex formula is the x value equals the opposite of b divided by 2 times a. So that's negative 250 divided by negative 50, which is equal to 5. So now that's our x value though, and our revenue is going to be the y value that we get out from that x value. So I need to take that x value and plug it back in. So I'm going to have y is equal to negative 25 times 5 squared plus 250 times 5. And just be really mindful of putting these things in parentheses and where you're going to put the power of 2. You only want to square the 5, not the negative 25. You don't want to multiply first. You got to take the power first. All those kind of things. You should, after you type this into your calculator, end up with 1,025. So I know I'm looking at $1,025 for a maximum revenue. All right, that's going to conclude our video for today. Thanks for listening. Don't forget to hop back to Schoology and take that quiz. I will see you tomorrow.